Okay, so let's start the session. Yeah, welcome guys, welcome to NEET World. In this session we are going to see the NSEP questions, that is questionnaire session this is. Okay, so let's start the session and let me open the questions first. Okay. So in previous session now we have discussed about what is NSEP, right, and who wants to apply the NSEP. Like the registration process is going to start now, so you can apply for that, and the preparation we will start from today's class. Okay. Wait for a second, it will open. Yes. Yeah, fine. So in the previous classes we have discussed about these things. Now we will go for the questionnaire session. So the first question of this class is, position time curve has been given, like position time curve of a particle moving along a straight line is shown. Tangent at A, tangent at B makes an angle 45 degree and 135 degree with positive x-axis respectively. The average acceleration of a particle during time t is equals to 1 second and t is equals to 2 seconds, and they are asking about acceleration, right? So what is the meaning of acceleration? We need to find the time, right? Acceleration, I mean we need to find the acceleration. So acceleration is nothing but velocity by time, right? Velocity by time. So if I I need to find the velocity. So for velocity, how can I find? Like they have given the tangent, right? Tangent of, yeah, tangents of A and B makes an 45 degree and 135 degree. And what is the graph they have given? Position and time graph. So a thing we can understand that position time graph, slope, that is slope, which is nothing but tangent, right? Tangent gives velocity, right? No, position time graph of slope gives velocity, right? No, so velocity we can find. Time they have given t1, I mean t1 and t2, time of A and time of B. Okay, time at A, time at B. Now velocity, no, velocity of A should be equals to tan, what is the angle they have given? 45 degree, tan 45 degree. Okay, what is velocity B? VB is equals to tan 135 degree, tan 135 degree. Now acceleration will be, acceleration is equals to VB minus VA by TB minus TA, right? No, that's it. So now what I should do here? VB is 135, VA is 35. So tan 135 degree minus tan 45 degree divide by 2 minus 1. That's it, no? 2 minus 1. 2 minus 1. So what I should do now? Tan 135. What is the answer for third? Tan 135. I can write tan 90 plus 45, right? Now 90 plus 45 degree. So we know that tan 90 plus theta. So whenever we see 90, 270, the trigonometry should be changed to the opposite. Like either sine should change to cos will be changed to sine, tan will be changed to cot. Okay, whenever we see 90 and 270, remaining 0, 180, 360, we can use the same thing, same trigonometry. Okay, so it is cot theta, and 90 plus theta, no, second quadrant only sign is positive, all silver teacups, na, only sign is positive, so it is minus. Now what is the value of this? So tan 45, I mean value will be, yes, minus cot 45 degree. So minus cot 45, it is minus 1 only, no, minus 1. So substitute the value. So it is minus 1, again tan 45 minus, I mean 1. So minus 1 divide by 2 minus 1 is 1. So answer is minus 2 meter per second square. This is the answer for the given question. What is, yeah, option A. So whenever they give a question like this, a graph, see first what is the given graph is, like with respect to which they have given. So from that we can analyze what is the given terms and what I need to find it. Okay. Once if it completed, we can go for the next question. Yeah, we'll go for the next question. Done. So the next question, yeah, a point A moves with the constant, yeah, it's not visible, okay, yeah, a point A moves with a constant speed of 20 meter per second, 20 meter per second. Now such that its velocity vector always maintains an angle of 60 degree with line AB. Line AB, it's maintaining 60 degree in the given figure, shows in the given figure. Initial distance between A and B is 50 meter. At what time A reaches B? A reaches B. Okay. Now what is the given terms here? Velocity is there and it makes an angle 60 degree with respect to the AB line. AB line, which means velocity in this direction, I should take a component, na? I should take the component. So if I take the components, so this is the line AB, right, AB, and this is my velocity given, I mean given velocity, right, 20 meter per second. This is the angle 60 degree, right. Now if I want to take the component, yeah, if I want to take the component, this is my cos, right, no, cos, only this thing I need, right, no. So what I should do, velocity is along AB is equals to, along AB, okay, is equals to V cos 60, I mean V cos theta, right, V cos theta, which is nothing but 20 into cos 60 is 1 by 2, which is 10 meter per second. 10 meter per second. They are asking about the time. Velocity is equals to displacement by time, where time is equals to displacement by velocity. What is the displacement happen here? 50 meter. 50 divided by 10, which is nothing but 5 seconds. So 5 seconds is the answer. Option C. Right, and we go for the next question. Done, right. The only thing is I need to take the components along this direction. So I have taken the components and substituted the values, so I can get the answer. Yeah, we'll go for the next part of the question. So here is the question. Two balls are projected from the top of the cliff with equal initial speed u. One starts at an angle theta above the horizontal, while the other starts at an angle theta below the horizontal. Okay, difference in their range on ground is. So Guys, one more thing, like whatever we are solving, no, it's like a previous year questionnaires only, okay? Either it can be in examination they've asked or whatever, like example problems or book back exercise, everything's are previous year questions, okay? Okay, I'll draw the diagram first, what they have said. So there is a cliff, okay? There is a cliff. One ball is projected with respect to the horizontal, like this, okay, and another ball is projected below the horizontal. So this one makes an angle theta here, and this also makes an angle theta, right? No, angle theta. So both are having initial velocity u, both are having initial velocity u, and they are asking the difference between their range. So delta r, range is r, no, difference between in the sense r1 r2 minus r1, r2 minus r1. So range in the sense like I need to find the distance. So velocity into time, no, we know that velocity is equals to displacement by time, the range, consider this as range. So range will be equals to velocity into time. So what will be the velocity along the horizontal? I need to take the component. So in this component will be u cos theta for both cases. So for this one I will consider time t1, for this one time t2. So u cos theta t2, u cos theta t1, write it now. So u cos theta t2 for range 2 minus u cos theta t1. So if I take the u cos theta commonly outside, u cos theta into t2 minus t1. So we know that delta t is nothing but t2 minus t1. I'll keep as it is. So what is the time taken to complete the projectile motion? It is one, like if I take a ball, if I project, if I give a velocity in this direction, in vertical direction, it will take to reach the maximum height at u by g. It need to come is 2u by g. Similarly, when it in the projectile motion, it is 2u sin theta by g, right? Yeah, it is 2u sin theta by g. Okay, 2u sin theta by g. Now substitute that value here. So u cos theta into 2u sin theta by g. So now if I write like this, if I can write like this, no, u square into 2 sin theta cos theta by g. So we know that 2 sin theta cos theta can be written as sin 2 theta, sin 2 theta. So which is equals to u square sin 2 theta by g. This is the difference between their range. So option is, which is the option given? 2u, u square sin 2 theta by g. So option 3. Option 3 is the answer. So it is u square cos 2 theta. It is not u square sin 2 theta, okay, by 2g. This also not, and u square tan theta by g. This also not the answer. So option 3 is the answer. We'll go for the next question. Okay, we'll go for the next question. I'll zoom it a little bit. Okay. A solid block of a mass 3 kg is suspended from the bottom of a 5 kg block, okay, with the help of a rope AB of mass 2 kg. So this rope is also having a mass. The blocks are there, the blocks are connected between the ropes, which is having a mass of 2 kg. When pulled by an upward force F, the whole system experiences an upward acceleration. So there is an acceleration, but which side? It is upside. Okay, this is the acceleration direction. So when we know the acceleration direction only, we can write the equations for the laws of motion, right? Yes. So choose the correct option. So the options are given like Tanveer Khan, hello, can I see which one, man? Yeah, you can see the questions, right? Yeah, it's not visible. Okay, now it's visible, I guess. Yeah, thank you. So this is my acceleration direction A. Now write the given terms, whatever they asked, I mean whatever they are given. Okay, so if I take the whole system, that is 5 kg, 5 kg plus 2 kg plus 3 kg, which is 10 kg. This is the mass of the whole system. When I consider the force here, if I try to pull it upward, the entire object will come, right? I am not considering only the block 5 kg. When I consider the block in this direction, no, everything will come. Only this block I should not consider. Okay, so 10 kg. We know that force is nothing but mass into acceleration. So F is equals to m into A. That is m total I should take. Total mass into acceleration. So what is the total mass here? 10 kg. 10 into what is the acceleration given? 2.19 meter per second square. So into 2.19, which is nothing but 21.9 Newton. Right now, is there option? Force F is 20 Newton. No, it is wrong. Net force on a rope AB is 24 Newton. Net force on a rope. Net force on a rope in the sense I need to find how much only on this rope. Okay. Then the tension at the midpoint of the rope AB. So midpoint of the AB, in this I need to find what is the tension. Force F is 60 Newton. This also not the answer. Let me find what is the tension here first. So tension in the sense here there is a force, right? I'll draw the free body diagram. Okay. This is my block, which is 3 kg block. 3 kg block, and the rope is like this. Like I have taken the half rope, only half rope. Okay, half rope in the sense this is my tension. This is my tension T. Okay, so there will be a weight mg, and this is my acceleration A. Okay, this is my acceleration A. So what about the rope weight? Rope weight is, I mean half of the rope weight 1 kg. Okay, half of the rope weight 1 kg. Yeah, half of the rope weight is 1 kg. So total kg, total mass is 4 kg. So tension in this direction it is going. Remember one thing, whenever acceleration is there, in that direction whatever force are available, keep in positive, and remaining force are in negative. Like opposite direction of the acceleration, whatever forces are there, keep in negative. So T minus mg is equals to ma. So what is T? I don't know. I need to find T. Minus what is the total mass? This is 1 kg, guys. This is 1 kg plus 3 kg, 4 kg. 4 into G is approximately 10. Okay, we will take is equals to, this is mass 10 kg into what is the acceleration given? 2.19. 2.19. Okay, 2.19. Now if I consider, yeah. Yes. Sorry, this is 4 kg, right? Mass is 4 kg into 2.19. Now it is T is equals to approximately I will get around 8 to 9, no 8 point something. So 8 I will keep plus 40, which is nothing but 48 Newton. So approximately I am getting 48 Newton, right? So tension at the midpoint of a rope AB is 48 Newton. So option B is the correct answer. So whenever you are having a rope of masses, you should consider the mass of the rope also, including with that blocks. Okay. So is there any doubt? We can continue with the next question. Yes, we'll go for the next question. Yeah, if the system shown in the given figure is released from rest at t is equals to 0, the relation between the acceleration of a block m, okay, small m, a1, okay, this is the acceleration a1 for the small m, and acceleration of block m, that is capital M, a2 is, okay, I need to find what is the relation between them. If I see here, no, I'll expand the diagram, like, okay. So if I see here, tension is acting, here one tension, yeah, one tension is here, one more tension is here, like same string na, this is same string, so T and here also T, okay. Now if I see here, these two strings are there, this is one string or one rope, so this one will be my 2T, here also this is 2T, right, 2T. So what will be the acceleration now? Acceleration will be 4A, I mean 4A2, so 4A2 is my acceleration in this direction, 4A2 should be equals to, then this is my acceleration. If I release, no, I need to take the component in this direction. So what is the component? Cos theta, which is A1 cos theta, that's it, 4A2 A1 cos theta. So what is the answer? Option 1. Option 1 is the answer, no? Yeah, 4A2 and A1 cos theta. I am taking the component in this direction, guys. I am releasing, no? When I release, like the string will go in this direction, right na? So 4A2 A1 equals to A1 cos theta is the answer. So we'll go for the next question. Yeah. A ball of mass m1 equals to 4 kg falls from height h1 is equals to 5 meter. So this is the ball of mass having 4 kg which is in the height of h1 from rest to strike another identical ball at rest. So there is another identical ball which is also having a mass 4 kg. So elastically and head on, okay, find the horizontal distance at which the ball strikes the ground from the position of its start. So if the ball is coming, if the ball is coming here and if it's the ball, what will happen? This ball starts moving, but it is in rest. So whatever velocity this ball is applying on this ball, only this ball will move. So whenever I find the velocity of this ball, I can use for this ball, right? Right, no? Right. So if I want to find the velocity, how can I find? If I drop a ball initially with respect to rest, u is equals to 0. U is equals to 0, V I need to find, A is equals to gravity, like freely falling body we have studied, na? A is equals to G, and displacement, that is H1, S is equals to H1. So V is equals to U plus AT, I can't use, V square minus U square I can use, na? A, T is there, T is I don't know, right, no? V square minus U square equals to 2A, yes. So in this 0, this is U square is 0, so I can neglect it out. So V will be equals to under root of 2G H1. So this is my velocity, guys, like the velocity of the ball when it's the another identical ball. Excuse me, yeah. So I need to find the velocity. So here what is the height given? 5 meter. So 5 meter, right? So under root of 2 into 10 into 5, which is nothing but under root of 100. So 100, which is 10 meter per second. So this is my velocity. I need to find the like distance, no, horizontal distance, right? Horizontal distance. So horizontal distance in the sense velocity I know, distance I need to find, but time is there. What is the time? So when a ball is falling from the height h, the time is t is equals to under root of 2h by g, 2h by g. Okay. So this time is when a ball is falling from a height h. So it is 2 into what is the h2? 5 meter. 5 divided by 10, which is nothing but 1 second. So 10 by 10 is 1, under root of 1 is 1. So I know the velocity, I know the time, I can find the range now. So range equals to velocity into time. What is the velocity? 10 meter per second. So 10 into 1, which is nothing but 10 meter. This is my range. So option 4 is the answer. Right, we'll go for the next question. Yeah, I'll zoom it. In the shown arrangement of two blocks and two light strings 1 and 2, if delta 1 and delta L1 and delta L2 are the elongation in the string 1 and 2 respectively, then so which are the correct options they are asking? Delta L1, like they have given the relation. So first we will find what is the relation for that. Okay, we will find the relation for that. So first I will find the string 1. String 1, like Young's modulus they have given, area and length they have given. So force in the sense tension is the force, right? Here string is there, so tension will be my force. So if I draw the free body diagram here, now for this 2m for the down string 1 block. Okay, this is the string 1. So tension, this is my weight, right? Now 2 mg. 2 mg. When I take the string 2, this is string 1. String 1. String 2. So string 2 tension is there. So T1, T2, T1, T2. So total weight, what is the total weight? 4 na? 4m. This is 4 mg. Okay, this one clear. Now go for the formula for the Young's modulus. What is Young's modulus? Young's modulus is nothing but stress by strain. Stress by strain. So what is stress? Force by area. What is strain? Change in length by original length. Change in length by original length, right? So write the take the denominator to the numerator, F by A into L by delta L. I need to find the delta L first, right now. So delta L will be equals to take the y to the another side, F L by A into y. So this is my formula to find the change in length. Now substitute the values whatever they have given. So first delta 1 I will find. Okay, delta 1. So delta 1 is equals to, so what is the force? 2 mg, right? String 1, 2 mg. 2 mg into what is the area? I mean length they have given. Length is L. L divided by, so area is A and Young's modulus is 2y. So 2y into A. So 2 will get cancelled. Answer will be mgl by ya. This is for the delta L1. So delta L2 will be, delta L2 is equals to, what is the force? 4 mg. Okay, 4 mg into L. Length is L, no? Force we have written length. Divide by Young's modulus is y, area is A. So ya. So if I see here, no, 4 into mgl by ya. So this can be written as delta 1, I mean L1 na. So delta L2 is equals to 4 delta L1. So now see the options. What are the given options here? So delta L1 is equals to 4 mgl by Ya. Delta L2 is equals to 2 delta L1 and delta L1 equals to delta L2 by 4. So this is correct option. Okay, I'll mark it this one. Delta L1 is equals to delta L2 by 4. Yes. And L2, delta L2 is equals to 4 times mgl by 4a. Option 3 and 4 are correct. Two options are correct. So two options are correct. Right now? So with this we'll end the session and we'll bring some more questions in the next session. So whatever doubts you are having, please give in the comment boxes. We'll clarify the doubts. Thank you guys. We'll meet in the next class.